Hello there. Another look today at finding probabilities for the normal distribution. Now, you remember last time I actually went through two different methods for finding probabilities. Method one was basically we try to use a Z formula. Z equals x minus mu over sigma. And from here we can then use either a table of values, which is not really ideal in these days, because effectively technology has overtaken those table values that we used to use, even only just 5 to 10 years ago. Or we can use the normal distribution functions on this calculator using this what's called a standardized variable. And I showed you how to do that last time. To be honest, it's much better using method 2, which is just to completely use the Classwiz. And when you use the Classwiz properly, you don't then need to worry about this Z, this standardized variable at all. But bear in mind, there are occasions when we've got no choice but to use the Z. So if we're finding probabilities effectively, probabilities, we will always, given the choice, unless it tells us not to, use the Classwiz. That's when it's brilliant. But there are occasions when the Classwiz isn't good enough. So let's bear that in mind, but then get on with this today. So a little starter for us, it's got a couple of questions. It says, if x is normal with mean 60 and sigma 5, find the probability that x is greater than 62. So these are both nice questions. You might want to pause the video, see if you can do them both yourself. I think they're exactly the same as we did last time in class. So pause the video now and I'll do the answers in about, well, as soon as you turn it back on. So, did you do them? I hope you did. Let's do number one. So it says x is normal, so I personally like to draw a normal distribution curve. Usually we're better bottom line than that, but there you go. In the middle I put the 60. And it says find the probability that x is greater than 62. So if I was to, I don't know, whatever this is, this could be the lengths of newborn babies or something like this, and on average they're meant to be 60. And I'm saying if I was to, the next baby that came along and I measured the length of the baby, what's the probability of that baby is longer than 62, presumably centimeters, or whatever units we're measuring these in. And so this is the probability I'm trying to find. Okay. And the way I do that is I get my menu 7 on my calculator, on the Classwiz. So I'm going to press menu 7. It comes up normal CD. That's one I always use. Never use normal PD. So normal CD. And it says the lower value. Now the lower value, because I'm doing this coloured in section here, that's 62. This is the lower. So I type in 62. The upper value is actually infinitely big. It goes on forever and ever and ever, but we can't write that in. So we just go 9999. And that always works. Sigma was 5, it says on the screen, and mu it says is 60. So you just the calculator just gives you the answer. It's 0.34 and I think 5 if I round to 3 significant figures. Question 2. See, that's relatively easy, isn't it? So question 2, we've got another normal distribution. Notice this is written just in proper notation this time. The mean is 35. That's the first number. But you should be aware that when they write this, that is the mean, but this is not the standard deviation. This is actually sigma squared. So that tells me that sigma squared, the variance is 6.25. I, on my calculator, have to type in this. It's the square root of 6.25. So I want you to type that into your calculator. You'll have to go menu 1 to get back out. Square root of 6.25, and you should find it is 2.5. Actually, my calculator says 5 over 2, but you get the idea. So 2.5 is that. So now I want, what's it want? The probability that the next, whatever this is, the next one that comes along is going to be less than 31. So I'm expecting all these things on average to be 35, whatever they are. It says, what's the probability less than 31? You can see I'm colouring at the other end this time. So on my calculator, menu 7, 2, normal CD. The lower value, well the lower value now is all the way over there. It is minus infinity. I type that in minus 9999. You can type a bigger number if you want. But just a few nines will sort out these answers more than accurately enough. The upper value is 31. Sigma I worked out to be 2.5, not 6.25, 2.5 because I had to square root it. My mean, my mu is 35. So I've typed those in, I pressed equals, and it gives me the probability. It says 0.0548. There you go. Nice and straightforward. And good, both answers are identical to what I actually got. Example then. Now look, this is what we have to be able to do in today's lesson. We have to be able to answer wordy questions. So exactly the same, but you just have to get to, get your head around what's going on. Assuming the heights of adult men are normally distributed with mean 174. So x, always use x, is normally distributed. The mean is 174. And standard deviation is 7. Now, the best way to write that is 7 squared. Remember, this is meant to be the variance. This is meant to be sigma squared. This is meant to be mu. So it's quite nice. Rather than writing 7 squared is 49, it's quite nice to go 7 squared. And then it reminds you that 7 is actually the sigma. You don't have to remember to square root it from now on. So if that's true, it says find the probability that the next adult man that comes along, who they measure, what's the probability, remember that's 185 down the middle, what's the probability that the next person is under 185? In fact, I've done that wrong. That was, the mean was 174. Ah, there you go. The mean was 174. What's the probability the next man comes along as under 185? Well, 185 is now over here. And they've said under, so I want to find this probability. So I go, probability that x is less than 185, and then I get my calculator out. I just do it on the calculator like before. So menu 7.2. I want all the way over here, so again minus infinity. So the lower is minus 9999. My upper is 185. My sigma is 7. And my mu is 174. Type them in, let it do the work. There you go, 0.942. Part 2. So that's part 1. Part 2. Over 180. So it's basically the same question, just slightly different picture. It might be wise to draw the picture every time. 174. 1, it says over 180. 180 is over here still. But I want this time it to be bigger. So this is exactly the same. The probability that x is greater than 180 equals, and menu 7.2 again. This time my lower number is 180. My upper number, well, it goes up and up and up and up and up, and eventually gets to infinity, but we can't type that in, so we go 9999. Sigma, what was sigma? Sigma is still 7, mu is still 174, and I get a probability this time of 0.196. Part 3. Squeezing all these on one page here. Between 180 and 185. Well, actually, in the old days, they were always much harder than the other questions because you had 2 things to work it with. But actually, with the new calculators, these are easier. There's 174. We want 180. We want 185. And we just want the probability in between those 2 values. So, let's do it. Menu 7.2 again. I've just had to press equals and it's come back. The lower number is 180. The upper number is 185. My sigma is 7. My mu is 174. And it just goes straight there. Probability that x is between 180 and 185 is 0.138. Now I've got one more, it says under 170, so I'll just do that as well. So there's my picture again. I'm expecting to get 174. It says under 170, I think it said. Yes, it did. So 170 is over here. You can see what I'm doing. It's exactly the same. Probability that x is under 170 equals. So the lower is negative 9999. I suppose that's the tricky bit. Upper is 170. And the other bits stay the same, 0.284. So, yeah, they look right. So, nice questions. Example. Skilled operators make a particular component for an engine. They believe the time taken for this may be modeled by the normal distribution with mean 95. So, x is normal with mean 95. and a standard deviation of 4 minutes. So again, just write comma 4 squared. Find the probability that time taken to make a randomly selected component will be over 97. So for part 1, we'll draw a little picture. What did it say? It's meant to be 95. And what's the probability over 97? Well, there we go. Type it in. So again, menu 72, menu 72. My lower number now, you can see that the lower number is this 97. My upper is the 9999. It's infinity. And again, I keep on saying this. You can't write infinity into a calculator, so you just pick a very big number. So I've got those two numbers in. What's my sigma? It told me the sigma is 4, and my mean was 95. So I'll type it in, press equals, and there you go. My probability that x is greater than 97 equals 0.309. Okay, done. The second part says under 90. So again, there's my picture. There's my 95. It's under 90, which is over here on the left of it. So you can see probability that x is less than 90 equals, well, what am I going to do? I'm going to go menu 72 again. It's under 90, so my left lower value is negative 9999, whereas my upper value is the 90. Look at my picture. That should try to sort it out in your mind. That's minus infinity over here to the left. 90 is my upper value then. My sigma is 4, my mean is 95, and I get a probability of 0.106. It's very easy when you're just typing them in. It's hard if you had to use proper methods. So we don't, so let's just take the easy marks. Now remember, the mean was 95, and it wanted it between the 90 and the 97. So there's the 90, there's the 97, it wants it between it. And I think these in-between ones are the easiest type on the new calculators. So you go, your lower is 90, your upper is 97, your sigma and mu are unchanged from before, and I get 0.586. Probability that x is between 90 and 97 equals 0.586. Now just briefly, yeah, they're right. So yeah, just briefly, just a reminder of modulus functions that we're going to need for what we're doing in probability. You should be aware of this idea of a modulus function. A modulus function makes negative things positive. So the modulus of 4 is still 4 because it was positive, but the modulus of negative 5, the minus I ignore and just pretend it's 5. So what this means is, if I write the probability that the modulus of x is less than 6, it basically says, well, x, whether I is positive or negative, I'm going to pretend it's positive. Now working backwards, it means it could have been negative. So it could have been minus 5, minus 4, minus 3, minus 2, etc. all the way up to positive 1, 2, 3, 4, 5, 6. So it basically means it can be in between minus 6 and 6. So this is slightly weird, and the probability that x is mod x, modulus of x, is bigger than 2. Well, it could be 2, 3, well, it can't be 2 because it says bigger than 2, but 3, 4, 5, 6, for instance. They are all examples of numbers bigger than 2. But remember, it says modulus of x. So that means these could have been all negative as well. So notice that means it's the opposite of being between 2 and minus 2, because I could have had 3, 4, 5, 6, 7, etc. And numbers in between. I could have had 3.5, of course. But one numbers that I couldn't have is anything between minus 2 and 2. I can't have those because the modulus of x has to be bigger than 2. So notice one way of calculating that is to work out the area in between, work out the probability of being between minus 2 and 2. And because all probabilities add up to 1, you can do 1 minus. So in class, I want to do this little example with you. And if I do those examples, then I think you'll be able to do all of exercise 17b. There's lots of questions in 17b, so I wouldn't be surprised if it takes more than one lesson. But other than that, let's have a go at that, and hopefully that's all clear. Cheers.